Hello everybody, this lesson is with factoring perfect squares. So perfect square binomials we've talked about. In order now to identify the pattern that these perfect square binomials have, we could actually multiply these out using the FOIL method. So first term times the first term, outside term times the outside term, inside times the inside, and last times the last. And we can do that to see this pattern. So you can think of a plus b squared as really being a plus b times a plus b. So if we use the FOIL method, first times the first, we get a squared. The outside times the outside, we'd have a positive ab. The inside two terms, so b times a, we'd have a positive, oops, not 2. We would have a positive AB, and then the last times the last, so B times B, we would have a positive B squared. And if we were to simplify this by combining these two terms in the middle, we would end up with A squared plus 2AB plus B squared. Similarly, if I do the other one using the FOIL method, so A minus B times A minus B, first times the first, we have a squared. The outside two terms would be a minus ab. The inside two terms would be a minus ab. And then the last two terms, a minus b times a minus b, would actually be a plus b. Think of it as a negative b times a negative b equals a positive b. And this also simplifies then by combining the two terms in the middle to a minus 2ab plus b squared. So looking at our two groups that we found, we have a squared plus 2ab plus b squared and an a squared minus 2ab plus b squared. We can kind of see the pattern. We can see that the first and the last terms are squared for each of them when you multiply. And this middle term is we are actually taking 2 times the first term times the second term. So looking at our original problem, that middle term is found by multiplying 2 times the first term times the second term, and that's how we get this 2ab. Same thing over here. 2 times our first term times our second term, that's how we get this minus 2ab. That's how we get that middle term. So keep in mind this pattern as we're going through more examples. So just to see it how with binomials that you would see in the lesson that you're working on, I kind of have it written as shortcuts here, where the first step you're going to square that first term. To get your middle term, you're going to multiply 2 times that first term in your binomial times the second term in your binomial. And to get the third term, you're going to square that last term. So first step, square our first term. If I square n, that's going to give me n squared. To get that middle term, I would be multiplying 2 times our first term. So 2 times our first term times our second term. And then for that last term, last step, square the last term, a negative 7 squared. Negative 7 times negative 7 is a positive 49. And then just simplifying, we end up with n squared. And then 2 times n times a negative 7. 2 times negative 7 is a minus 14n. And then we have plus 49. And you can multiply these out using the FOIL method, but it helps to recognize the pattern, and you'll see why in the next couple slides. So just know that for the pattern, you're squaring your first term and you're squaring your last term. And to find that middle term in your trinomial answer, you would multiply 2 times the first term times the second term. So 2 times n times a minus 7. Over here, if I square my first term, 3x squared, so 3x times 3x, my first term is going to be 9x squared. That middle term is found by multiplying 2 times my first term, so 2 times 3x, times my second term, so times 6. And the last term is squaring my last term. So 6 times 6, or 6 squared, we end up with 36 here. Combining these two together, 9x squared plus 2 times 3x is 6x. 6x times 6, we have a plus 36x here, and then plus 36. So again, the pattern, you're squaring the first term in your binomial, and you're squaring the last term in your binomial, and that middle term is found by multiplying 2 times the first term times the second term, and that's how you get that middle term in our binomial. Knowing this now, we can actually work backwards. By working backwards to determine if a trinomial is a perfect square trinomial, you're thinking about the questions that you asked to get it there. So I kind of have it broken out here. You want to ask yourself, is this first term in my trinomial a perfect square? So is 4x squared a perfect square? If I were to take the square root of this, I would end up with 2x. So this one, yes, I can answer yes, it's a perfect square. And then is my last term a perfect square? So my last term is 25. If I were to take the square root of that, I would end up with 5. So yes, this one is a perfect square. Now that middle term is kind of the tricky part. This is saying, is the absolute value of the middle term twice the product of the square roots of the first and last terms? Basically, what it's saying is that term either the positive or the negative form of multiplying 2 times what the number we found here, so 2x times 5. So this square roots of the first and last terms, that's why we square rooted here. Square root times, or the square root of 4x squared is 2x. Square root of 25 is 5. So if we were to check 2 times 2x times 5, it should equal the absolute value of this middle term. So 2 times 2x is 4x. 4x times 5, we do get a 20x. And the absolute value of a negative 20x is still 20x. So yes. Whoops, that circle did not end up over my yes. This one is a perfect square trinomial. So again, walking through, is the first term a perfect square? 4x squared is a perfect square. What is the square root of that? We found 2x. The last term, is 25 a perfect square? Yes. The square root of 25 is 5. So then to determine if that middle term fits the pattern, multiply 2 times the square roots that we found. So 2 times 2x times 5. And we got 20x, and that is equal to the absolute value of this term, because this could be plus 20x or minus 20x and still fit a perfect square trinomial. One more example of working backwards. Let's check the first two questions. They're the easier ones. So 16x squared, is this a perfect square? Yes, because the square root of 16 is 4, and the square root of x squared is x. So 4x is the term. If I multiply 4x times 4x, I would get to 16x squared. Question 2, is the last term a perfect square? So we're looking at 9. 9 is a perfect square, and the square root of that is 3. So this one is yes. Now to check that middle term, I want the absolute value of this. So whatever I multiply out should equal the absolute value of a negative 12x and have it be a perfect square trinomial. So we're checking 2 times our 4x times our 3. Those are the square roots that we found of the first and last terms. And it should be twice the product. So twice when we multiply this, 2 times. So 2 times 4 is 8x. 8x times 3, this multiplies out to be 24x. This 24 does not match that minus 12x. So no, this one is not a perfect square trinomial. So it definitely helps to have these notes down to look back on, but the easy ones, check if the first and last terms are perfect squares. To look at that middle term, you're multiplying 2 times the square root of those first and last terms, and it should match that middle term, either plus or minus. It should match. If it doesn't match, then it is not a perfect square trinomial.